Greetings to all. Welcome to the channel Simtech05. So the first and most important point is you need to create the stage 2 itself in the same CE file. For that, what you will do, you double click on the model and say stage 2, and of course standard and explicit, click on OK. So now stage 2 is created, but there is no part. Let me quickly create the punch and die for the stage 2. Say tool, axisymmetric, wire, discrete rigid. Continue. So this is my die, and let me offset complete chain and with value of 3. Yeah, in this direction itself, click on OK. This is my punch, but not this portion. So let me delete the portion that I don't want. Okay, and let me move the punch, or we can keep it here itself. So we can see this is my punch and this is my die. So how to keep punch and die in different parts? So let's copy that and say any name, separate, and click on OK. So these two parts will be created, T1 and T2. So this T1 is nothing but my die for stage 2 and rename, and this is my punch for stage 2. So where is blank? Blank we will call from the stage 1. So how to do? Say right click on the part, click on import, and we want to import the formed first stage component. So what is a form component? This will be our result file actually, and the result file is nothing but ODB file. So stage 1 ODB file that we have to call, but not the complete file. We have to call only the blank. So this is blank and the blank name. This is very important. Okay, naming is here very important. Whatever name you considered in the stage first, the same name you have to consider for the blank in the stage 2. Say in stage 1 I have blank name as blank. In stage 2 also I have to define the same name blank blank in the same format. And do we want undeformable blank? No, we want a deformable, or we can say deformed means or final formed component. From the step 1, of course, we have only one step in the stage 1, that is explicit dynamic 1, and then frame, the last frame I want to call. Okay, and now click on OK. So this component will be, this blank component will be import from the ODB1. For that you have to set the property, the same material you have to create. Let me check the material for the stage 1 and blank material. What I'm going to do, density 4.8 e raised to the power minus 9, elasticity parameter 180 e raised to the power 3 and 0.3, and plasticity parameter. Okay, so these I have to create here also, the same material. Do not create different material. So say blank material and general density, the density was 4.8 e raised to the power minus 9, mechanical elasticity 180 e raised to the power 3 and 0.3. 3 and plastic parameter 180 0 600 0.2. So this material I create a section. Say this is not a cell section, okay, this is the solid section because this is axis symmetric model, that's why it look like a cell, otherwise it's a solid component. So what type of section you will create? A solid section you will create for the blank. Continue, blank, and assign. Create node by angle, individual, select everything and select the blank section, dismiss. Properties assigned, go to the assembly. Now the assembly is also important. Why? In assembly you have to make sure you should not move the blank component, okay? Blank component position will remain fixed. You should move the punch and die component. Go to the move, say this one is die. This die I wanted to move from this point to approximate here. It will not shift in the x direction because it is the axis symmetric component. It will come again in the z alignment. Likewise, yeah, this position is quite okay for me, and the punch position is already okay. Okay, punch position is already okay. If you want to move little up, you can move like this. So this is my punch, and similarly I can move the blank little up from this point to this point. Okay, little more. Okay, that's okay. Now click on okay. So you have to make sure blank position remain fixed. With respect to the blank, you have to move the punch and die and other component. So first thing, we imported the blank component from the ODB file. Second thing, we should not move the blank component. Now go to create the step, say stage 2, dynamic explicit, oh I'm sorry, create dynamic explicit stage 2 and time period of 0.01 second, non-linearity on, automatic, click on default output request. Now interactions here play important role. Just collapse the stage 1 and make sure you are in the stage 2. In the stage 2 assembly, go to the surfaces and say the blank surface, not the blank, punch surface, geometry, select not individual, biangle. Okay, the magenta and yellow in the same direction, so you can select out of them. Yeah, of course, this blank is going to be contact from the yellow direction, so yellow one, this die surface, geometry, and this also I have to select. Okay, magenta, and here I have to change the direction. Go to the flip, select the surface, the magenta, and now okay, magenta one. Now see, these are the elements. Blanks having only element and node, it don't have any geometry. So how to create a surface? By mesh. Say blank top, and this is my blank top. Okay, Oh, I need to create a node region. I need to create a node region, not the mesh. So go to the sets and node. Of course, you can select those elements also, but I want to select the nodes. Blank top, nodes, instead of individual, feature angle, and select the one node, and the all node with feature angle 20 will be select. Similarly, press shift button and select likewise. Now select the blank bottom, feature angle. Okay. Now go to the define interaction. First, let me create a property. Frictionless contact property and normal behavior hard contact with separation. Say punch. Okay. So surface to surface and go to the select surface, punch surface, highlight. This punch surface will be in the contact with the blank top, and blank top is not a surface region, it's a node region. Blank top, and now click on continue, select the parameters and click on OK. To define in stage 2, let me move in the initial stage. Similarly, for the die surface to surface contact, die 1, node region, blank bottom, and click on continue, click on OK. So in this way you have to define contact for the stage 2. For the stage 1 you have to simply select the surfaces of the blank and surfaces of the tool, and very easily you can do. But in stage 2 it is little bit tricky because we imported the blank component, we don't have geometry for the blank component. So after that you have to define the load. This is again the very important task. Okay, first let me create the reference point for the die component, tool reference point, and this is my reference point for the die, punch, tool reference point, and this is reference point for the punch. Now you can select reference point here, here, anywhere you want. Loading. Go to the fix what? Of course die, symmetry, and select from the viewport, select this reference point, click on geometry, click on create blank. Why we are going to restrict the blank? Because it's an axisymmetric model and we want to restrict the x direction movement. Okay, u1 x direction movement we want to restrict. And next for say punch displacement, geometry, let's say initially it's fixed in the all direction. Okay, let me check the distance from this point to this point. I have distance of 96.21. so punch parameters for the stage 2, let me add it in the y direction, negative, and just paste it. Okay, 96.21, but we don't want the exactly 96.21 distance, we want a gap equal to the blank, and the blank thickness is 3, so it will become 93.2. let's say amplitude, again smooth step amplitude I have to create at time of 0, 0 at time of 0.01, the amplitude is 1. Select the amplitude, OK, and go to the dismiss. Okay, till now there is no issue in the loading condition, but we have to import the blank results from the stage 1. Okay, see, when we call this blank for the stage 2, only the element are called. Okay, result are not imported. So what to do? You have to go here in the predefined field or predefined manager. Go to the create, go to the initial step, other tab, and here we have initial state. In the initial state, let's continue. Select the component for which you want to define initial state, of course the blank component, for which I have results from the previous step. Okay, and that previous step, not a step, previous stage. Okay, the stage first, and in that stage first we have the job name as, let me check, here we have job name is stage 1. So the same stage 1 name you have to define, and you want to import the result from the last step. Of course only one step we have, so if you have multiple step and from that you want to import result of a specific step, you can specify, and the frame, the last frame you want to call, or we can say the last frame result we want to call, and click on OK, and now this will be assigned. Now click on dismiss. Now we can say the model, the blank component from the previous stage first is imported, as well as the result also imported. So go to the mesh, let's say seeding, default seeding, it's okay. Similarly for the die, go to the assembly again, save the file, go to the job, and let's create a new job with name stage 2. Parallelization, even no need to give the parallelization, this is the simple model. Let's monitor the results. With some warning, the simulation is started, and even it is completed. Why it is 4.02 second? I think I made mistake. Say step time 0.01. Job, let's monitor again. Okay, it's showing total time. Yeah, it's a step 2, start after 0.0. Okay, fine. So click on dismiss and click on results. So here we have results. Blank is somewhere else. This will automatically adjust when you click on that deform. Go to the primary stage, first stage, and we can see in the first stage, not stage, in the first frame of the second stage, see the animation not yet started, but we have few results same as stage 1. So let's open those results also, job, and click on result. These are the stage 1 result. Go to the create one more window, here stage 1 results, and here I want stage 2 results. See, in the stage 1, the maximum stresses we have 5.9 e raised to the power 2. The same result imported for the stage 2 and at the beginning of the animation. Of course, the result will be changed when we change the frame, but initially we have same stresses as stage 1. So in this way we can say we successfully import our blank component as well as we imported results also, and these results imported from the stage 1 help to perform the stage 2. Not only the stress result here, as I told you the earlier, plastic strain, and here also you can check the plastic strain, the same 1.77 and 1.78, yeah, little deviation because of the frame. Now go to the 0th frame, 1.776, 1.776. Okay, so that's all for these video tutorials. This technique not only helps in the multi-stage farming simulation, it helps a lot when you have such combination of explicit and general static type of simulation. Say I want to perform a coupled thermal structure simulation with the explicit step, then I want to see the cooling effect. So performing the cooling analysis for the 300 second or for maybe 1 hour, maybe more than 1 hour, performing such simulation, such cooling simulation in the explicit step is near to impossible. So what you can do, you can call the results from the explicit step, and with the help of those results you can perform the cooling simulation in general static step. So not only this, apart from that you can do many things. This is just a gateway to understand this technique. There are infinite possibilities to utilize this methodology. So thank you for listening. If you have any query or question, you can ask me in the comment section or you can mail me. I also have Facebook and Telegram group. You are most welcome to join that community.